In a previous video, I've shown you how to change a binary value to two BCD values and how that is then displayed on those two different 7-segment displays. In this video, I'm going to show you how to change a binary value again to BCD to be displayed, but in this case on 3 7-segment displays. So what I've done here is I've just created this Proteus design. In my previous video, which I've also given, I've shown you how to display, let me just stop this thing here. I showed you how to display the ones and the tens. So I'm adding the hundreds now on 3 7-segment displays. Again, I'm making use of an Atmega 328P, which is an AVR microcontroller. On port number D, I'm displaying the ones and the tens. And you'll see also that I make use of port B, the lower nibble of port B, to display the hundreds on this 3 7-segment displays. In this specific case, on port B, I'm using the lower nibble for the hundreds, and in this specific case, I'm using on port number D. Port D, I'm making use of the lower nibble to display the ones, and I'm using the upper nibble to display the tens. And of course, from my ports, the two different port D and port B, I've got my BCD to 7-segment display decoder. So if I've got, for instance, 3 displays, that means any value between 0 and 999 can be displayed on this specific displays. So if I go to, I've written the program in Atmos Studio, and again, my focus is not really on Atmos Studio, it's just a generic program which I use to display it on Proteus then. So if I go to the program that I've used, what you see here in yellow is my program. You'll also see that when I later refer to Atmos Studio. What I've done is I've declared 3 variables here, low, mid and high, and I've also declared display val as the value that I want to display. But you'll also see here that I've used an integer as the value can go up to, I want to display up to 999, and a char is not suitable for that, of course. A char can only go up to 255. So this is why I've made use of an integer. So then I've in my program just declared port D to be an output. This is how it's done, and the same with port B, it's declared as an output. And then I would start in the program and say that the variable low is equal to display val modulus 10. Now in my previous video I've shown that the moment that you start using modulus, it is something that's divided by 10, so the display val will be divided by 10, but we're not interested in the whole value. I'm interested only in the remainder. So this is exactly what I'm doing here. So display val, as I've said, is I'm taking an example of 123. That's what I've originally declared it as. So here it's 123. This is the binary value of 123, and as you can see, there's if I want to display that as it stands at the moment, it is meaningless. I cannot use that as it is. I have to break it up in a BCD value representing 3, in a BCD value representing 2, and a BCD value representing 1. And then I can display it on a 7-segment display. So where I've used this statement here, low is equal to display val modulus 10. That means you divide 123 by 10, which will give you 12, but I'm not interested in the 12. I'm only interested in the remainder, which is 3, and that is what I will capture. And that will be placed in low. So low will eventually have this value in it, which is 0, hex 0 there, and hex 3 here. But the main thing is that 3 has now been sort of stored separately. So I've got the value of 123, but I've now stored. I've taken out 3, and it sits in low. Now the next statement in this specific case is where mid is equal to display val divided by 10. So display val did not change. It's still 123 because it hasn't changed. So it's 123 divided by 10, which then when you divide something, the comma 3 is actually then discarded, and I'm sitting with a value of 12 in mid, but I can't really do anything with that 12. So in the next line, what is going to happen in my program is I'm taking mid now, which is 12, and if I modulus that by 10, again it is divided by 10, but we're not interested in the whole value. I'm only interested in the remainder, which is in this specific case, if I say mid modulus 10, it will be 12 modulus 10, so we keep the remainder only, which is 2, and that is now placed in mid. So now we can see how this thing starts to develop. A 3 was stored. The 3 that you see here is now stored in low. The 2 is stored in mid. So all we need to do now is get something like high and store the 1 in there. And this is what I've done here. High is equal to display val. Again, display val did not change. It's still remaining 123. And if that's divided by 100, it is 123 divided by 100. And we will sit with an answer of 1. Because if you divide the comma, the decimal comma, that disappears. And we're only sitting with 1. So high has got the value in it of 4 zeros and 0001. So what I've done here on port D, as I've already explained previously, is I took mid, which is this one sitting here. Sorry, it's this one here. And if you move that 4 positions to the left, that 0010, which is 2, will be placed in the upper nibble area, and this is what we see. Well, this is what we see after we have ORed it. So in this specific case, if I say mid, move it 4 positions to the left, it will actually go and sit in the upper nibble section. And low, we know what low is. Low is this one here. And if we OR them together, we will sit actually, because this is now sitting in the upper nibble position, the answer will be that one, and in the upper nibble, which is 2, and the lower nibble part will be 3. So port D will actually display a 2 and a 3. Again, this I have explained this in my video, which is converting binary to BCD, but only 2 digits. So if you want to have more detail there, go and have a look there. Okay, on port 3, this is port B is equal to high, and we know that high contains the value of 1. We've seen it here already. And basically I'm only interested in the port B0 to PB3. But yeah, basically the lower nibble will be placed on port B, and if I go to my Proteus design, as we've seen here on port B, the lower nibble now contains a 1. So if I load this program, I've already preloaded the program in Proteus. If I tell this thing to run, let me just stop a little bit. I just want to quickly change the value in the program to 123. Let me just build it, and then I can program it again in Proteus. Let's just stop, let's start, and it will display 123 as I have explained in the program. So if I go to my Atmel Studio program and I maybe change this display val to something like 246, let's just build it and then get back to Proteus, stop and start again, and it will display 246. And let me just do one maybe just to show you that it can show 999. Let me just build it again, and if I go to Proteus and I stop and I start, it will then take the new value and it will display 999. So in this way I can actually display, let me just get back to the program, I can display any value in my program from 0 to 123. I can just maybe show you another example, just one more example of, let's just display something like 78. Let me just build it again. There you go. And if I go to Proteus and stop and start, you will see that this here, it will display 78, but here it will display a 0. So it can display anything from 0 up to 999. In your program, of course, I have now just taken a few examples where I've changed display val by changing the physical value, but of course in a program you display val will normally be changed, like for instance in an ADC, so display val can continuously change, and then you can just slightly change your program and it will display 3 digits on your 7 segment displays. And this is how it's done. Thank you.